So good afternoon, everyone. Thank you for participating in this webinar. I am Carolina Milesi, and I am a principal research scientist at NORC. I will be hosting this webinar along with my colleague, June Park. As the title of the webinar suggests, the goal of this webinar is to better understand how to make a comparison across subgroups using data from the National Survey of Early Care and Education, or NSECE. We will focus on unlisted home-based providers, and we will compare paid unlisted home-based providers and unpaid unlisted home-based providers. We will define these terms shortly as we go along. A couple of housekeeping items to get started. If you have any problems with the audio, please use the chat function or email us at nsece@norc.org. You can also use the chat function to send comments or any questions you may have along the way. We expect to post the webinar recording in the future. And in the meantime, you can follow us at any time. The best way to communicate with us is to send us an email at the nsece@norc.org address. The agenda for today. I will start with a brief overview of the NSECE and describe the key steps involved in making subgroup comparisons. My colleague June Park will then provide 3 examples from the 2019 NSECE and will compare estimates between, as I said, unlisted paid and unlisted unpaid home-based providers. And I will close the webinar with some time for Q&A. So let's start with the overview of the NSECE. The NSECE is sponsored by the Office of Planning, Research and Evaluation, OPRE, at the Administration for Children and Families in the U.S. Department of Health and Human Services. The OPRE team is composed of Edilis Martinez-Peck, Ann Rivera, Bonnie McIntosh, and Ellen Liskowski. The project team is led by NORC at the University of Chicago. The project director is Rupa Dara. And since 2007, partners have included Chan Trends, Chapin Hall, and many other excellent independent researchers. My apologies there. The NSECE provides information on early care and education services available to families in 2 types of settings. The NSECE includes home-based providers that serve children under the age of 13, and it also includes center-based providers that serve children ages birth through age 5, not yet in kindergarten. The NSECE also provides information on the characteristics of the workforce providing these early care and education services, and the households with children under the age of 13 that might use these services. This webinar is a second webinar in a 3-part series that aims to provide guidance for 3 common types of comparisons researchers may want to use or do with the NSECE data. 2 weeks ago, we hosted a webinar on comparison across survey years, in which we compared the 2012 listed home-based providers to the 2019 listed home-based providers. Today, we will focus on making subgroup comparisons, and we will compare 2 subgroups within the 2019 survey and 2 specific groups within the unlisted paid home-based providers. 2 weeks from now, we will also host a webinar that focuses on comparing sample types within the same year. So let's talk about the NSECE design. Today, we will focus on this survey, the home-based provider survey that surveys unlisted home-based providers. I will briefly describe the NSECE, the overall NSECE design, so that you understand where the unlisted home-based providers fit in. This figure shows the interrelationship among 2 sample sources and 4 NSECE surveys that are at the foundation of the NSECE data collection design. The 2 rectangles on the extremes, on the right and the left side, represent the two NSECE sample sources. And each of these rounded boxes, these 5 rounded boxes, represent the a survey, and the diamond-shaped boxes represent the screener instruments. The NSECE includes 2 types of home-based providers. On the right here, we have the provider sample. These are home-based providers who appeared in state and national lists. We designated these providers as listed. Listed providers were primarily licensed or regulated family daycare providers, but also include other formally listed home-based providers, such as license-exempt providers or providers participating in early Head Start. On the left, we have providers that did not appear in this provider sampling frame and are designated as unlisted. These providers were identified as eligible based on their responses to the household screener. So this is the household sample. From the household screener, the unlisted providers were identified. Specifically, the screener identified that an adult in the household regularly cared for children, not his or her own, at least 5 hours per week in a home-based setting. So these are the providers that will be the focus of today's webinar. And this is what I meant at the beginning by the unlisted home-based provider. The NSECE design is quite complex, and this is a very brief introduction. So if you want to know more about the NSECE design and the content of each of the questionnaires, I would encourage you to listen to the webinar listed in this slide, titled Getting to Know the 2019 NSECE. Because the NSECE has a complex design with oversampling and other sampling features, we strongly recommend that you always use sampling weights when analyzing the NSECE data. The most significant oversampling in the NSECE is of areas with high densities of households under 250% of the federal poverty level. Analysis that is done without the sampling weights would only represent those respondents, the respondents who answered the survey, and not the broader population. And that's why we encourage you to use the weights. Each NSECE dataset includes the weight variable and also 2 design variables listed here, the strata and the primary sampling unit or clusters. The design variables are needed to account for the multi-stage stratified cluster sampling used in the study. So in this slide, we list the specific variables that you will need to analyze data from the unlisted home-based provider data file. Okay, so let's talk now. Oh, I apologize, I skipped one slide. Today's webinar will rely on data from the quick tabulation file for unlisted home-based providers. A preliminary version of this data file and documentation is available online. In order to access these data files, you will pass through a registration. You will click on this link, you will pass through a registration page, and then you will be given a link to download the data file and documentation directly. You are not required to provide your email address. You can skip this and still be able to download the files. We at NORC only use these emails to addresses to notify you of updates and new resources available related to the NSECE. So let's talk now about comparing subgroups. Subgroup comparisons allow users to compare estimates across subgroups. Any estimate can be compared, including weighted totals, means, and proportions. And the examples that we will cover today will each of them address each type of these estimates: a weighted total, a mean, and a proportion. Today's webinar will cover 3 examples. All examples compare 2 subgroups: the unlisted paid home-based providers and unlisted unpaid home-based providers. The first example will cover the total number of unlisted home-based providers by this subgroup variable. The second example will cover the number of children cared by unlisted home-based providers, also by subgroups. And the third will cover the reasons unlisted home-based providers report as the main reason for caring for children, also by the subgrouping a variable that is payment or paid or not paid. There are 4 key steps for conducting subgroup comparison, and the rest of the webinar will keep referring to these 4 steps. The first step is to identify the subgrouping variable and the measurement variable. So in the examples that we will provide, the subgrouping variable is payment or no payment, and you will see the different measurement variables. The second step is to prepare the data set for subgroup analysis. The third step is to calculate the weighted estimate and the standard error for each of the subgroups that you will be using. And the fourth and last step is to conduct significant testing to ascertain whether differences across your subgroups are indeed statistically significant. So let me briefly describe each of these 4 steps in general. So your first step, as I said, is to identify the subgrouping and measurement variables. And for these, we will strongly recommend you to use the quick tabulation manual and codebook. You see a screenshot of that here, of the codebook here. The quick tabulation data file only includes the unlisted home-based providers. For additional variables, researchers may turn to the home-based provider main data file, which includes both the listed and the unlisted home-based providers in the same data file. You can use the variable sample source to separate out only the unlisted providers if you were to use that data file. This is the same way in which the 2012 NSECE data files were structured, with the quick tabulation files including either unlisted or listed and the main data file including both. As we noted earlier, the home-based provider data covers providers who regularly care for children under the age of 13. I will point out that some of the analysis produced with the 2012 NSECE data reported only for the subset of home-based providers who care for at least one child ages 5 or under. Today's estimates will include home-based providers that serve any child under the age of 13. So one of the key steps will be for you to define the subgrouping variable, and you can use the quick tabulation codebook to do that. The key point that I want to make here is that it's important for the subgrouping variable to have mutually exclusive categories. So in this example, you could use region as your subgrouping variable, and for instance, to identify them, to estimate the number of unlisted providers in each of the regions, and you will read the documentation and realize that the regions are indeed mutually exclusive. It's also important to examine the measurement variable construction and check the skip patterns. The quick tabulation manual has a lot of information about skip patterns. So for instance, here you will see a note that says that for this variable, which is chart training, this variable is based on the item, on survey item J10. And the variable construction says that this item was asked only of non-relationship-based providers and also relationship-based FCC-like providers, whether or not they reported having higher education. So this item, J10, was not asked to all unlisted home-based providers, but only those 2 subsets. And this actually means that non-relationship-based providers are providers who care for at least one child without a prior relationship. And then relationship-based providers are providers who only care for children with a prior personal relationship. And we asked this item to relationship-based providers who had some of the characteristics of family childcare providers. It's also important to make sure that the variable you are using as your measurement variable was asked in the same way to all subgroups. So if you were to use, for instance, the relationship-based provider determination as your subgrouping variable, it would not be a good idea to choose this variable char certification, because this variable was only asked to, wasn't asked to all relationship-based providers, was only asked to the relationship-based providers who are FCC-like. So again, check the skip patterns, check the documentation in the quick tabulation manual, to make sure that your subgrouping and your measurement variable are appropriate. The quick tabulation manual also includes unweighted frequencies and weighted percentages and weighted summary statistics of the variables, and you can use these to check missing data, check the size of each of the subgroups, check the number of groupings. So in this case, you will see all that information here. So your second step is to prepare the data set for subgroup analysis. And there are two important points here. The first is that you need to use a statistical software that allows you to take into account the complex sample design of the NSECE in your estimation. Major statistical softwares such as R, Stata, or SAS have their own functionality for handling complex survey design. Today, we will provide you example syntax in Stata, but this can easily be adapted to other major statistical software. The second point that I want to make is that you need to make sure that you are using the full population in your estimation and not deleting or dropping any cases that you aren't using in your analysis. This is important. It's important that you rely on the entire sample to get the appropriate standard errors. So the third step is for you to calculate the weighted estimates and standard errors for each subgroup that you are considering in your analysis. When using this statistical software, you will be using the correct design variables and weight variables. The weights affect both the estimate and the standard error, while the design variables only affect your standard error. We would strongly recommend you to review the estimates for each subgroup, including the review of the point estimates and also the review of the standard errors. A small sample size in one subgroup may result in low statistical power. And this is why the review of the unweighted size of each of the subgroups is recommended upfront. Finally, step 4 is for you to conduct significant testing for comparing the subgroups. If your subgrouping variable has more than 2 categories, you may need to carry out a post hoc adjustment to control for family-wise error rate. And in general, you would want to conduct the statistical testing to identify whether the differences that you identified across groups are statistically significant or not. And with that, I will turn it over to my colleague, June Park.
Hi, my name is June Park, and I'm a research methodologist at NORC. Today, I'm going to illustrate the 4 steps in subgroup analysis using examples. So for the examples, we'll explore 3 research questions. The first is the difference in the weighted total number of unlisted home-based providers differ by payment type, that is paid and unpaid? The second research question is there a difference in the mean number of children cared for by unlisted home-based providers by payment type? And the third research question is, does the percentage of teachers and caregivers who identify career-related reasons as the main reason for caring for children differ by provider's payment type? So we have all these 4 steps for doing the subgroup analysis. For step 1 and 2, identifying the subgroup and the measurement variables and preparing the data set for subgroup analysis, we'll show the step 1 and 2 for research questions 1 through 3 simultaneously. And for step 3 and 4, calculating the weighted estimate and standard error for each subgroup and conducting significance tests, we'll do these steps separately for each research question. So the first step is identifying the subgrouping and the measurement variable. In defining the subgrouping variable, which is the payment type, this variable is called HB9 program paid. And you first want to take a look at the documentation and the codebook for 2019 NSECE to learn more about how this variable is defined and constructed. So the label from the codebook says this variable defines provider payment status, paid versus unpaid. And this variable is also a constructed variable. So how is paid or unpaid defined in our variable? The variable construction note in the codebook tells us that a provider is considered paid if they receive payment for at least one of the children that they care for. On the other hand, a provider is considered unpaid only if they do not receive payment for any of the children that they care for. This constructed variable is constructed using survey questionnaires, item B23 _N for small providers, and for larger providers, this is constructed using C12 and C20A. And you can learn more about how the large and small providers are defined, as well as the original wordings of the survey questionnaires used to construct the variable. After you have reviewed the variable label and its definitions and the original survey questionnaires, you also want to check out the distribution of the variables that's included in the codebook. You see the unweighted frequency as well as the weighted percentage for this variable. Looking at the frequency and the distribution of this variable can be very helpful before doing the analysis to get a sense of how the subgrouping is distributed across. So once you have defined the subgrouping variable, the next step is to clearly think about the research question and define the measurement variable as well. So for the first research question, which is comparing the weighted total number of unlisted home-based providers by providers payment type, you want to get the total count of the provider, which is not from a direct survey questionnaire, but rather it can be generated using an indicator variable. For the second research question, which is about comparing the mean number of children cared for by unlisted home-based providers, we have a variable HB9 _ enroll total. For third research question, which is about comparing the percentage of teachers and caregivers who identified career-related reasons as the main reason for caring for children, we have a variable called HB9 career _ reason. So jumping to research question 2, which uses HB9 enrolled total. Using the codebook, we can learn that this variable provides the total number of children cared for by home-based providers for 5 or more hours per week. And this is also a constructed variable. So you'd want to read the notes on how this variable is constructed. Once again, this variable is constructed using survey items. So you'd want to also take a look at the survey items as well. HB9 enrolled total is a continuous variable. So if you look at the codebook for this variable, you will see the mean and 10th, 25th, 75th, and 90th, and minimum and maximum for this variable is provided. Looking at the weighted mean for the HB9 enrolled total is 2. For research question 3, which uses HB9 career _ reason, this variable is defined as the main reason for working with young children. And this variable is also a constructed variable from the survey items. Therefore, you can take a look at the question to get the original wording of the survey item used to measure this variable. This variable was constructed using the survey item, and the responses were grouped into broader summary categories. We have career reasons, help children, parents, earn money, conventional work arrangement, convenient work arrangement, other and don't know and refuse as the categories included in this categorical variable. The weighted percentage for the providers that chose career-related reason as the main reason was 12.97%. After you have clearly defined the subgrouping and the measurement variable in step 1, the next step is to prepare the data set for subgroup analysis. As we have mentioned before, NSECE uses a complex sample design. Therefore, in all estimates and analysis that we do, it's important to use a statistical software that can adjust for the survey design. This is a sample output from Stata. And as you can see, we have added HB9 method weight as the weight variable, and the HB method v-stratumpu and HB9 method vp-supu as the two design variables. The second thing when you prepare the data set for subgroup analysis is that you want to ensure that the full population is in the data set. We strongly advise against dropping any cases, but instead to use subset functionality that may be built in your statistical software to subset the group when necessary. You can also consider recoding any of the don't know refused, in our case, the unpaid category and relabel the category as unpaid or payment not indicated. And this allows you to keep the all observations in your analysis. Alternatively, you could also consider reporting the subgroup with don't know refuse as its own category. The third step in our analysis is to calculate the weighted estimate and standard error for each subgroup. For research question 1, is there a difference in the weighted total number of unlisted home-based providers by provider payment type? We first generate an indicator variable for estimating the weighted total and estimate the weighted total and standard errors for each of the subgroup. This is a sample output from its data. As you can see, I have first generated an indicator variable, count equal 1. And this output shows 0 is the unpaid provider, unlisted providers, and 1 is the paid unlisted providers. So the estimated weighted total number of unpaid provider is about 4 million, whereas for the paid providers, the unweighted total is about 1 million. This output also has the associated standard errors and the confidence intervals with them. After you have estimated the point weighted total for each of the subgroup, the next thing you can do is to do a hypothesis testing to see if the difference that you see is statistically significant. The null hypothesis that we want to test in our research question 1 is that the difference in the weighted total of the unpaid and paid provider is 0. Some statistical softwares allows you to have a very easy way of estimating, have a convenient way of performing t-tests for survey data. And today, I'll show you some outputs from Stata using the coefficient legend option and the linear combination function. Even though I'm using Stata as an example output for today, doing the hypothesis testing for comparing the difference is essentially doing an independent sample t-test to compare the means of the two independent groups. So you can find other statistical softwares or other ways of doing the t-test. So this is an output after putting the coefficient legend option. And you see for the row for 0, we have, and under the legend column, we have the associated legend for the coefficient, which allows you to do a very easy t-test very conveniently using the linear combination function, where you test that the difference between the estimates of the two groups is equal to 1. The difference in the point estimate is provided in the output, along with the standard error of the difference. The t-statistic is 14.37, and the associated p-value is 0, which is very low, smaller than the widely used significance level of 0.05. So we have enough evidence to reject the null hypothesis that the weighted total number of paid and unpaid unlisted home-based provider is 0. To summarize, we have about 1 million unlisted paid providers and about 4 million unlisted unpaid providers. And this difference that we observed is statistically significant. The second research question is there a difference in the weighted mean number of children cared for by unlisted home-based providers by payment type? For this research question, we're using a continuous measurement variable, which is HB9 enroll_total. We'll use the appropriate procedures to get the weighted mean and the standard errors for each group. We use the survey mean function available in Stata to get the estimate. And this is again an output from Stata. For the unpaid unlisted providers, the mean number of children cared for is 1.83 compared to 2.83 for the listed providers, for the listed paid providers. So after doing step 3, you can do step 4 to see if the difference in the mean number of children cared for is different from 0. The null hypothesis, just to state it again, is that you want to see if the difference in the mean number of children cared for by unlisted home-based providers between unpaid and paid provider is 0. So immediately after doing the estimation command, you can use the coefficient legend and linear combination function to perform the to-sample t-test. This is the output to get the coefficient legend for each of the estimate for the unpaid and the paid provider. And using the linear combination command, you can test whether the difference is different from 0. The difference in the coefficient from step 3 is about -1. The standard error for the difference is about 0.15. The t-statistic is -6, and the associated p-value is 0. This again provides enough evidence to reject the null hypothesis that the difference between the point estimate for the enrolled number in the mean number of children cared for by the provider is different from 0. To sum up, the number of children cared for, the average number of children cared for by unlisted paid provider is about 3 compared to 1.9 for unlisted unpaid providers. And this difference was statistically significant. For research question 3, does the percentage of teachers and caregivers who identify career-related reason as the main reason for caring for children differ by provider's payment type? We are using the measurement variable HB9_career_reason. And this variable is a categorical variable. And we want to generate a dummy variable that indicates 1 for cases that chose career-related reasons and 0 otherwise. And then we can use appropriate procedures to get the weighted percentage. So this is once again example output from Stata. You can see that I have used a survey proportion to get the weighted proportion. And I have coded chose_career as 1 if they have chosen a career-related reason as the main reason. So you can compare the rows with 1, 0 and rows with 1, 1. So for 1, 0, the rows with 1, 0 indicator which is unpaid providers that chose career-related reason as the main reason. That's about 10%, compared to 21% for the paid providers that chose career-related reason. So after step 3, you want to conduct the hypothesis significance testing to test if the difference is 0. So the null hypothesis you want to test here is that the difference in the percentage of teachers and caregivers who identify career-related reasons as the main reason for caring for children between paid and unpaid providers is 0. So you can once again perform the independent t-test using the coefficient legend and linear combination function that's available after doing the estimation command. So the legend that's associated with the 0.10 is provided under the legend column along with the legend for 0.21 for the paid providers. And using the linear combination function, you can test whether the difference between the two groups is 0. The difference is about 0.11, negative 0.11, and the standard error is 0.03. The t-statistic is still pretty large, about -3, and the associated p-value is 0.001. So this again gives us enough evidence to reject the null hypothesis that the difference between the two groups is 0 at the widely accepted 0.05 significance level. To summarize, the proportion of teachers and caregivers that chose career-related reason as the main reason for caring for children was about 21.4% for unlisted paid providers, compared to 10.1% for the unlisted unpaid providers. Our hypothesis testing suggested that there is enough evidence to reject the null hypothesis that the difference in the weighted percent is 0. Therefore, the difference between the two is statistically significant. So this concludes our 3 examples for the subgroup analysis using 2019 NSECE, and we are now opening the floor for question and answers.
Thank you, June. Are there any questions? Brian, that people have posted in the chat?
I don't think so, not yet, but we will keep an eye out.
Okay. So while you type any questions you may have, I want to recap briefly. So these are the 4 steps that we covered in terms of how to do appropriate comparison across subgroups in the NSECE. You first identify your subgrouping variable and your measurement variables. So in this case, today, we presented as a subgrouping variable payment type, and measurement variables were the count of providers, the average number of enrolled children, and the career reasons. Your second step will be to prepare the data set for subgroup analysis. And we show you how to appropriately set your data so that it takes into account the complex survey design in the NSECE. You will need to use the variables that we provided here, even though in your statistical package of choice, you will kind of set up the data differently. The command may be different. The third step is to calculate the weighted estimate and the standard error for each of the subgroups in your analysis. And the fourth step is to conduct a significant test. The same 4 steps work for any comparison you may want to do, either kind of any comparison across any subgroups or any other comparisons. Today, we discuss kind of within survey subgroups, but the 4 steps are applicable for different types of comparisons. And these are the links where you could download preliminary versions of each of the quick tabulation data files and documentation. So there is the center-based provider data file, the workforce data file, the listed home-based provider, unlisted home-based providers. And finalized NSECE data files will be available on the Child and Family Archive. The link is provided there. And you can sign up for any future updates on the NSECE data here. For additional information, there are multiple resources for downloading for kind of in general about the NSECE. The first one here are tools for using the NSECE. There's kind of various tutorials in this stage. There's also the OPRE NSECE page and publications. And these are a couple of examples of recent reports and publications. The 2019 NSECE questionnaires are also publicly available, and you could download them at this site. And recently we posted a few slides on resources that you could use to plan the your 2019 or 2012 to 2019 comparison analysis. And there are some good pointers there. So again, any questions or suggestions you may have about the NSECE data, you could reach us at nsece@norc.org. And if there are are there any questions or comments?
Carolina, real quick, would you mind please elaborating on your advice not to drop cases that are not in someone's analysis sample? Because it seems to become a common practice to drop the cases that you're not using in your analysis.
Yes. So, June, you could add anything I may miss here, but I agree, it's very common that, let's say, you only want to use in your analysis the subset of providers located in a region. So you simply drop the providers located in all other regions, and that affects your standard errors because your statistical software will think that your sample is a lot smaller than it actually is. So your standard errors will be larger than they have to be. And so what you would, for instance, in Stata, you would basically say, calculate any estimate you want, and you say the actual relevant sample is this, region equals 1. And that way, the software understands that you are doing the estimates on a subset of the data file, but that the entire data file contributes to your estimates. June, is there anything you would want to add?
No, I think just add on to what Carolina described just now, I think it's a very good point. A lot of the times when doing the subgroup analysis, you might just find a group that's not a group of interest, but dropping those cases from the whole sample, you're just basically dropping those cases with the associated, weights and all the design variables. So we strongly advise against doing that, but include them in your whole analysis. Just to get the correct standard errors for the estimate.
If you were to drop the cases, your point estimate, let's say your average, your proportion, will be correct, but the standard error associated with that estimate will be larger than it has to be.
Yeah.
Any other questions, Brian?
I don't think so.
Okay. Well, we thank you very, very much for taking time to join the webinar. We're welcome to receive any questions. If you have trouble accessing any of the materials that we linked here online for any reason, please reach out and we will make those documents accessible to you in some other way. And thank you very much. We are looking forward to hearing back from you and potentially seeing you in 2 more weeks for the next webinar. Thank you.